Today is the 5th of March 2024, and I would like to talk about recurring and terminating decimals today. We want to look at that again. Okay, thank you everyone who has subscribed, who is sharing, liking and following us. I appreciate it a lot. Okay, please, as even though I want you to subscribe, if the account is not yours, ask permission from the account holder. Very, very important. Okay, and then share, like, follow. Okay, nice comments. It will be very well appreciated. And then you can also ask somebody to help you open your account, which is easy to do. Okay, and then you can use the account so that when we upload, you get your own notification. Okay, in the comment section I normally write, please follow my note/script. So for instance, this is 2y, 2 all into bracket y plus 4 bracket close. Okay, so if you hear anything apart from that, go by what is on the note. Okay, and linking to your account, beware of scammers. Take very good care of yourself. Okay, online is a very good and positive thing. Okay, and then I think with time, most people might do things. Even now, people do things online, but that is where we have these people, scammers. Okay, people have made it their job to scam people. Okay, unlike initially, before somebody they have to break through your house. Now, as long as they can break through your account online, they've got you really. They don't have to take the risk and do that. And some people are expert at that. Okay, so please beware of scammers. Don't be chatting with people who are saying that, on behalf of this platform, can you donate this? Can you donate money? Can you donate money for this cause? I'm not using this platform for that. I'm just trying to put out what I know can help people who don't have Gcse, people who want to go back into education to just help themselves, or people who are in education and are struggling a bit with especially maths. Okay, because the general knowledge we know, science has maths, biology has maths. Okay, so if you can be good at maths, then you can be good at some of the basic, geography, history. All this subject has an aspect of maths in them. So at times, even drawing, at times you have to do measurement and stuff. IT has maths. Okay, so if you can get your maths Gcse, people have Gcses and they don't have maths. And unfortunately, because they don't have that, they can't even have an access course, even though they did well in other subjects. Okay, so please, this platform is supposed to help you, not to scam you. So if you are online, just beware. Okay, now recap. We've been doing a lot of graph work, okay, in the past couple of weeks. Okay, I've bombarded you with the archive, and histogram videos, giving you a lot of graphs, done a lot of examples with you to go and think about. At this level, even if you are doing a higher paper, I think I've given you a lot to go and think about. The questions you are going to get, they are the same questions that they repeat. They just tweak it a bit every year. Okay, so please, if you are doing a higher paper, go back and watch. They can give you the table and then you have to draw the graph. That is what we normally do, but they can also give you the graph and the part graph, and then you have to deduce the table, or they can give you part graph, part table. Okay, whatever way they throw the questions at you, at this moment, if you watch the videos and take it a little at a time, maybe one video at a time, watch it, go back and think about it, come back and watch it, solve the questions, make sure you understand them, so that when you go to the exam and it comes, because if you understand something, it's likely you might not forget, even if you don't revise that thing, that topic, the night before the exam, because you understand it and you know how to solve it, you should be good to go. Okay, so once again, good luck to everyone doing their exams this year. From the bottom of my heart, I wish you be very well in your body, well in your mind, so that you can do the best for yourself, and then at the end of the day you'll be happy. Okay, now example, our starter today, we did a video on functions, so I just wanted, this is a foundation non-calculator paper. Okay, so this is an exam paper. Okay, and I wanted to throw it as a starter. Okay, but the fact that it's a foundation question doesn't mean that you cannot have this question as question 1 in a higher paper. Okay, so let's have a look. Okay, now the first one, you have an input. So assuming you are putting something in a machine. Okay, for instance, if you put a frozen food in a microwave, after 3 minutes it comes out in a different form. Okay, so in chemistry, you can put a solid, like a liquid, like water, in a freezer, and then after a few hours, it comes out as a solid. This, we are looking at it mathematically. So you have an input of y, then you add 4. So now you have y add 4. Then you times all of that by 2. So now you have 2 into bracket y plus 4. Okay, They didn't ask us to expand. So under exam condition, I would leave my answer this way. Unless they ask us to expand. Even if you expand, you still get the answer like 2y plus 8. But I would leave my output as that because I should be conscious of time. So this will be your output, 2 into bracket y plus 4. Now another one, you have an input of a, okay, you subtract 7, so you now have a minus 7. You divide by 3, so you now have a minus 7 all divided by 3. C, you have p, you subtract 1, so you have p minus 1. You times 4, so 4p minus 1. So now your output will be 4p minus 1. Okay. As I said, unless I'm being asked to expand my answer, I will leave my output as this way. Okay. I wouldn't go ahead and expand. If it's in the classroom work, then maybe I'll use the expansion bit as an exercise or a revision exercise. But if it's getting an exam or a mock exam, I'll just leave my answer this way because you've not been told like expand your output. Okay. So if you follow the machine systematically, you shouldn't go wrong. So you have an input of p, you take it through minus 1, you multiply by 4, and that will be your output. Okay. That is our starter. Go back and think about it. Today, we'll look at recurring decimals, particularly, and terminating decimals. Okay. Now, a terminating or recurring decimal depends on the denominator, whether the decimal will terminate or recur depends on the denominator. Okay, so for a fraction a over b, it depends on what kind of denominators you have. We've done prime factors. Okay, go earlier and watch. Okay, so for instance, if the denominator has only prime factors such as 2 or 5, okay, so 2 is a prime number, 3 is a prime number, 7 is a prime number, 5 is a prime number. Prime numbers prime numbers are numbers that can divide itself in 1. If you divide a prime number, you get that number in itself. Okay, so for instance, 2, if the factors are 2 or 5, okay, or both, then, or the powers of these, then this will give you a terminating decimal. What does a terminating decimal mean? For instance, 1 over 4, okay, the 4 in the denominator is 2 to the power 2, okay, so, or 2 times 2, So you are going to get 0.25, which terminates. Okay. So, also, because of place value, okay, and the powers of 10. So for instance, 10 is 2 times 5. So if it involves 2 and 5, they are going to terminate. Okay. So for instance, 3 over 8, the denominator here 8 can be written as 2 times 2 times 2, which is 2 to the power 3. Okay, and the prime factor here is 2. Okay, we are talking about prime factors, not factors. So it means you are going to get a terminating decimal. Terminate means it stop. Okay, so for instance, 0.375 terminates. The same way, another denominator of 8, 1 over 8 will give you 0.125. It stops. Okay. 7 over 20, you are going to get 0.35. That also stops because the 20 is 4 times 5. And then the 4, you can write it as 2 to the power 2 times 5. So prime factors 2 and 5. Okay, so you are going to terminate. 3 over 20, 0.15. That also stops. Okay, so now that is how you realize that it stops, it terminates. But when it doesn't stop, when it goes on, so for instance, if you have 0.11111, then it's reoccurring, or 0.173 is reoccurring, or 0.231 is reoccurring, or 0.2929 is also reoccurring. Okay, now if it terminates, has to involve 2 and 5 as prime factors, then the other prime factors, as long as it's involved in the denominator as prime factors, then they are going to reoccur. So if the denominators has any prime factors other than 2 or 5 of these factors, then the decimal will reoccur. Okay, for it to terminate, you need to have the prime factors of 2 and 5. So 2 or 5 or both. But if you have any other prime factor like 3, 7, then it's going to reoccur. So for instance, look at this example, 5 over 9. Okay, it reoccurs because here the 9 can be written as 3 times 3. Okay, so that will be 3 to the power 2. So even if you use your calculator, you get 0.555555. It continues, it never stops. It will go on and on and on. That is a reoccurring fraction, a decimal, this one. Okay, so this type of fractions will give you a reoccurring decimal. So as I've said, the denominator 9 equals 3 to the power 2, which is 3 times 3. Okay, so it doesn't involve 2 and 5. Another one, 2 over 9 reoccurs, so you're going to get 0.22222 on and on. It goes on. 7 over 15, it also reoccurs, so you're going to get 0.466666. Okay, it will continue. Now why? Because the 15 here is 3 times 5. Even though you have 5, this 3 is not 2. Okay, if you had a prime factor of 2, then it will terminate, but because of the 3, it will recur. Okay, 2 over 15, 0.13333, on and on and on. It will go on forever. Okay. Now, I've shown you this in one of our videos, but as a way of recap, okay, change fractions into decimals. Okay, you can, in the beginning, we did some of this work. Okay, so now you have 3 over 8. Straight away, you know it's going to terminate, because 2 times 2 times 2, the prime factor here is what? 2. Okay, so now we put 8 out, and then we have 3 in our box. 8 cannot go into 3, so you put a decimal on top of 3 and you add a 0. How many 8s do you have in 30? 3. 3 times 8 is 24. 30 minus 24, you have 6. Okay. Then you add 0, because 8 cannot go into 0. How many 8s do you have in 67? 7 times 8, 56. When you subtract, you have 4. Okay. As long as we haven't got to 0, we have to do another 0. So add 0 to 4, you get 40. How many 8s do you have in 45? 5 times 8 is 40. So that's why 3 over 8 will give us 0.375. Here it terminates. We've done this in our earlier videos. Go back and watch. Okay. So this is how you can change a fraction into a decimal. Okay. Now, here you can see it terminates. Okay. Let's quickly look at another example, and then we'll bring this lesson to a close. And then tomorrow I'll bring more stuff to show you. Okay. After doing a lot of graph work with you, I just wanted to relax you today. Okay. Whilst you go out and revise, these are questions that come, okay, in both higher and foundation. So if you know what the denominator is, the prime factors, you can really see whether it will terminate or reoccur. They can give you a question like, which of these which fraction will terminate, and then they'll give you 4 fractions, or which fraction will reoccur in one of our possible exam questions. We saw a question like that. Okay, so guess by knowing the denominator and what prime factors they contain, okay, then you can easily see, or you can, if it's a calculator paper, you use the calculator to check. If it's a non-calculator paper, that is another way to check. Guess by looking at which one has prime factors of 2 and 5, which one has prime factors of 3, as I've shown you. Okay, so let's look at another example. Change terminating decimal into fraction. Okay, so we've changed the fraction into decimal. Now we want to look at how we change the decimal into fraction. So we have the same fraction, 0.375. Okay, now underneath the numbers after the decimal, we are going to put 3 zeros. Okay, place value. And then after the decimal, we put a 1. So now we have 375 divided by 1,000. Okay, now if you divide, if you are not like it's not a calculator paper, divide both numerator and denominator by 5. You get 75 over 200. Divide again numerator and denominator by 5. You get 15 over 40. And you can still break it down. So divide both numerator and denominator by 5. You have 3 over 8. Okay, so as I've shown you, you can change a fraction into decimal by going by the long division method, which I've done here. Okay, or you can change a decimal into fraction by going by this place value method here. Okay, so this is what I have for you today. After giving you all those graph work today, I thought I'll come with something simple. Okay, these decimal and fractions, you can get them in the foundation paper, you can get them in the higher paper. Okay, so it is a good thing for us to just have a look at it again, even though I have dealt with it in earlier videos. Okay, please subscribe, share, like, follow. Nice, very good comment. I will appreciate it a lot. Beware of scammers. Thank you so much for watching today's video, and I'll see you in the next.